Hello. Thank you for coming to this session. Hello, my name is Masanori Yamaguchi. I am an AWS community hero. I work as an executive officer at Forge Vision. Today, I talk about how to implement a well-architected incident response or AWS. Here is today's agenda. First, my security incident response matters. Why security incident response matters? Understanding the risk in the starting point. Next, the importance of preparing for it in advance. Preparation is key to fast and accurate response. Then how to organize and prepare response procedure. This includes essential tasks for containment and acquisition. Finally, how to automate the playbook to ensure reliable and repeatable execution during an incident. AWS Well-Architected Framework has 6 pillars. Today, we focus on the security pillar. It has key areas like identity and access management, detection, infrastructure protection, and also incident response. Let's think again. Why is incident response so important? We cannot control when a security problem happens. It can happen anytime, just like an accident. That means it's not maybe someday. It's maybe today. That can happen at any time. When it happens, your company is in trouble. Sometimes it's a big crisis. So we must act fast. We must find the problem and start recovery. That is why we must always be ready. The security pillar explains the life cycle of incident response. It starts with preparation. Then comes detection, analysis, containment, and recovery. This shows us one important thing. We must be ready before an incident happens. Being prepared is the key to taking the right action when something goes wrong. Here are 4 steps needed to recover from an incident. Every step in incident response is important, but containment and acquisition are the most critical. The attack must be stopped from spreading. Key data must be collected before it's lost. Attackers may try to easy evidence or expand their access. Quick and accurate action is essential. To confirm recovery is complete, data is also needed to clearly define the scope of recovery. That's why containment and acquisition must be done early and reliably. Let's take a look at how containment is actually done. AWS provides many documents about containment, but information is spread out. You can find guidance in the security pillar, the incident response user guide, and prescriptive guidance. So what do these documents say? They list many important actions. Isolate the instance, rotate credentials, stop compromised resources, remove from autoscale, and load balancer. Restore access with security group and S3 resource policies, very important. Now let's also look at acquisition. This area is also well documented. Guidance include how to take snapshot, capture memory, and collect logs. The challenge is the same. Information is scattered across many documents. There are even more documents available in acquisition. Some of them are published only in specific languages. Having lots of documents is not having lots of documents is not a bad thing, very good thing. But when information is spread out across many sources, it can take time to find the exact steps needed, especially during an incident. that can be concerned. Based on these documents, I summarized common acquisition steps. Enable termination protection, take snapshot of each EBS volumes, collect instance metadata, capture memory, perform live response, disk, memory, logs, and etc. Let's review the key point and the challenge of incident response so far. First, preparation is essential. And containment and acquisition must be done quickly and accurately. The challenge is that the required steps are documented, but not in one place. Information is spread out multiple AWS documents. To address this, a set of common essential tasks has been extracted from those documents. These tasks are shared across many scenarios and are the foundation for building reliable playbooks. Here are the essential tasks for containment. These tasks are divided to 5 steps. Each step is designed to stop the incident from spreading and protect the environment. One of the targets the instance to indicate its investigation. Two detach AWS IAM instance profile or attached isolation security group. Next, here are the essential tasks for acquisition. These tasks are grouped into 4 key steps. There are to support effective investigation and recovery. Let's think about how to prepare a playbook for these tasks. Manual execution is possible, step by step. Tool can also be used to support the process. But which option is the best? The answer is automation. Next, the reason why automation is such a powerful choice will be introduced. Automation is very important in incident response. When an incident happens, we are under very strong pressure. We will stress, and we must act fast. In this situation, it's easy to make mistakes. Automation helps us avoid errors. Less human work means fewer mistakes. It also saves time and reduces risk. That's why AWS strongly recommends automating incident response tasks. This is AWS prescriptive guidance. It provides best practice for automation, both incident response and forensics tasks. It helps design reliable and repeatable process during high-stress situations. The guidance mainly focuses on automation using AWS Lambda. Next, several automation options will be introduced. Now, let's look at AWS services we can use for automation. There are many options, like AWS Lambda, Systems Manager, and step functions. In the next slide, we will focus on 2 popular choices. Lambda, which is used in AWS prescriptive guidance, and step function, which support workflow orchestration. Lambda is powerful and very flexible, but it needs programming skills, like Python, Node.js, or other programming languages. It can also be hard to read and maintain. Step function is easier for many teams. You don't need to write code. You can see and build the workflow visually with Workflow Studio. It gives better visibility and is easier to manage, especially when multiple steps are involved. At the time, there was no situation using only step function to automate incident response. So I decided to build one. This state machine runs containment acquisition step automatically. The steps are based on AWS Well-Architected Framework, and other official documents. I review those materials and pick up the key actions for response. They turned them into a working solution. Here are the 9 steps this state machine performs. Each step is part of the containment and acquisition process. Together, they help us isolate the instance and collect key data. In the next slide, I'll walk you through each step briefly. The first step is to add a tag to the instance. The tag is under investigation. This helps other teams know the instance is being handled. It's a small step, but very useful. If the tag cannot be set, the state machine will stop. It's shown an error message and exits. When automating multiple steps, error catching and handling are very important. Next, the instance must be protected from accidental deletion. Terminated protection is enabled, and the shutdown behavior is set to stop. These settings prevent the instance from being terminated during response operations. Next, instance metadata is collected. This information helps identify the system state at the time of the instance. Key details such as the instance ID, instance type, instance address, VPC and subnet IDs, security group, and launch time are recorded. This value provides important context for investigation. Now, tasks 4 to 9 run at the same time. This saves time during an incident. Parallel execution is one of the strengths of step functions. For parallel execution, I use a parallel state in step functions. Inside these states, each task runs independently. Snapshots are created for attach each EBS volumes. Encryption must be enabled. And an EBS tag is added for identification and tracking. Next, the set delete on termination attribute to false or EBS volumes. This ensures that volumes are not deleted when the instance is stopped or terminated. Next, detach IAM instance profile. This is critical security step. Detaching the IAM instance profile blocks access to other AWS services. This prevents the compromised instance from causing further damage. Also, the instance is detached from the auto-scaling group. This prevents automatic termination or replacement. It also helps maintain the desired number of healthy instances. If the instance is part of a target group, it should be deregistered. This stops traffic from the load balancer and prevents the compromised instance from responding to requests. All existing security groups are detached from the instance. An isolation security group is then attached. This group has no inbound or outbound rules, effectively cutting off all network traffic. In some cases, capturing a memory dump or backing instance store volumes may be required. This can be done using AWS System Manager run command. These steps are currently planned for future implementation. Okay, let's review what we covered today. Security incidents can happen anytime, so preparation is very important. During an incident, Automation helps learn key steps quickly and correctly. Choose a method that is easy to maintain and not tied to one person. The state machine for essential incident response tasks can help during a well-architected incident response into your environment. Okay, you can try the state machine I introduced today. It's available on GitHub. Please feel to use it or customize it for your environment. Thank you for your time. I hope so this content help for your work or your team. Thank you.